I welcome you all to this structural dynamics course. In this module, we will discuss about the structural dynamics, that is the introduction to structural dynamics. So, the outline of this course is as follows. So, first we will discuss about single degree of freedom systems, dynamics of single degree of freedom systems, and then dynamics of multi degree of freedom system, as in like regular buildings. And then where we cannot idealize systems as a single degree or multi degree, system is continuous, for example say chimney, okay, or say towers. So we discuss the dynamics of continuous systems. And then the systems which are rigid in nature, rigid blocks. Okay, so non-structural elements are usually rigid in nature. So where sometimes displacement is a critical issue and sometimes force is a critical issue. So we discuss dynamics of rigid blocks. And in some cases we need to control the vibration. So we discuss. So the outline of the entire course, it goes as like this: single degree, multi-degree of freedom system, continuous systems, dynamics of rigid blocks, and vibration control. These 5 elements are there. So now how this is spread in 12 weeks. So in first week we will discuss about free vibrations. So in that we will discuss first the analysis types, and then how to formulate stiffness matrix, and what is the meaning of degree of freedom or kinematic indeterminacy. So then we will formulate equation of motion for single degree of freedom system, and then find out its solution. So this equation of motion, we have 4 categories in this: free vibration, forced vibration, undamped free vibration, damped free vibration. So all those things will come. And in week 2 we will discuss damped free vibrations and what types of dampings are present in the system, and how the energy is removed from the vibrating system and what law it follows. So that we are going to discuss in second week. And then how to formulate equation of motion using energy principles, that we will discuss in week 2. And in week 3 we will discuss undamped forced vibration. So when force is acting on the system, and then if damping is present, how this response of the structure is going to change. And like when force is acting, so in some cases there are special cases where forcing frequency and natural frequency of the system, if both matches, what kind of response is going to come out. So that is resonating responses. So what is resonating displacement, resonating velocity, and resonating frequency we will discuss. And we will apply this principles of single degree of freedom system in different applications. So one such application is, say if a vehicle is moving on the road and the road is imparting because of its not smooth, because of its bumps, what kind of force is imparted onto the vehicle, and what reactions like what how the vehicle is interacting with the road. So that transmissibility we will discuss in week 3. And in week 4, okay, all first week and second week, third week, we will discuss the dynamics using forces which are more or less sinusoidal in nature. But in week 4 we will discuss how to solve the systems where arbitrary force is acting on that. So response to arbitrary force, response to step force, response to linearly varying force, and response to pulse excitation. In addition to this one, we will understand how a dynamic equilibrium equation can be solved in using a Fourier transform methods. And in week 5 we will discuss about numerical methods. So numerical methods based on interpolation of the function, and numerical methods based on finite differences, and numerical methods based on variation of acceleration. So in this we discuss 2 methods with example, that is central difference method we will discuss, and then Newmark's method. And week 6 we will discuss a response spectrum, how a spectrum can be developed and how spectrum can be used for all engineering applications, and the energy present in the vibrating system and energy present in the input ground motion or input signal. So those things we will discuss in week 6. And week 7 we will go to multi-degree of freedom systems. So how to formulate equation of motion for multi-degree of freedom system and how to solve it. So modal analysis. So how to derive the 2 important parameters, which are natural frequency of the system, fundamental natural frequencies, and then mode shapes of the system. and then what is the relationship between each mode shape. So that we'll discuss, and quite often it becomes that finding out the first fundamental natural frequency is important. So for that, approximate methods to find out instead of going to tedious multi-degree of freedom system calculations. We'll discuss approximate methods for finding first natural frequency. And in the next week, if multi-degree of freedom system or a regular building is subjected to earthquake, how do we get the response? This has two components. One is we can do time history analysis and get the response, and other is the response spectrum analysis. So we develop response spectrum of the given signal and use that response spectrum for finding the response of structure subjected to an earthquake. And in week 9 we will discuss 3D dynamic analysis or a regular building. So how it oscillates in two translational directions and rotation in the a torsion. So all these three put together, how equations are going to change and how do we find the solution of that. So this will be more realistic in nature. And then later continuous system, vibration of continuous systems, and then followed by that dynamics of rigid blocks or its applications to non-structural elements. Lastly, we'll discuss vibration control. So how vibrations can be put under specified limits. So for that we have two broad categories. One is active control and second one is passive control. Some examples of active control, how the input motion is fed to the system and then take active reduction vibration amplitude. Passive control in the form of base isolation, tune mass damper. So in these 12 weeks we will cover the entire course on structural dynamics, starting from single degree, multi-degree, continuous systems, 3D, 3-dimensional systems, and vibration control.